In this video, we'll go over some examples of stoichiometry problems that involve solutions. In our first problem, we are looking at the reaction of aluminum with copper 2 sulfate, and we're asked what mass of aluminum is required to completely react with 35 milliliters of 0.15 molar copper 2 sulfate. So again, let's look at the question that we're being asked for. What mass of aluminum? Okay. Of course, we solve stoichiometry problems just like any other conversion problem. So mass of aluminum is an amount, so we're going to start with the amount that's given. Remember, even though it looks like 1 unit, the big M for molarity stands for moles per liter. I usually tell students when they see the big M to go ahead and cross it out and write in moles per liter. That way you can see the units, and we use the units to help us decide what the math is supposed to be. Okay, so that means that our given amount is the 35 milliliters of copper 2 sulfate. So we go ahead and start with our given amount, 35 milliliters of our copper 2 sulfate solution. And now we compare the unit that we're given with the unit that we're asked for. So we're given the volume of a copper 2 sulfate solution, and we're asked for a mass of aluminum that are involved in our chemical reaction. And of course, these are not the same physical quantity. What is the only bridge that we have that relates the amount of one product or reactant in a chemical reaction and another? Of course, we know that that's the mole ratio. So the mole ratio, which we get from our balancing coefficients, will be the bridge that we use for this problem, as it is in all stoichiometry problems. However, the unit that we're given is not moles of the copper 2 sulfate, it's the volume of the solution. So the first thing I'll have to do before I can use my mole ratio is convert from the volume of the solution to moles of copper 2 sulfate. And what is the bridge that converts the volume of a solution to moles of solute? Well, that's the concentration, in our case, molarity. We know that molarity is in terms of moles per liter, but I was given my volume in milliliters, so even before I can convert to moles, I need to convert my volume to liters. Because that's just a metric conversion, I'm going to do that by going ahead and moving the decimal. So I have 0.035 liters of copper 2 sulfate. Now I'm ready to use my molarity to put that into moles. What unit goes on the bottom to cancel is liters. So I have 0.15 moles of copper 2 sulfate in the numerator. Now I'm ready to use my mole ratio. And where do I get a mole ratio? From the balancing coefficients. I have moles of copper 2 sulfate in my numerator now, so I need that in my denominator. I'll bring the balancing coefficient along with it. 3 moles of copper 2 sulfate. And what am I looking for? I'm looking for aluminum, so I'll bring the balancing coefficient for aluminum along with that, and that will go in the numerator. And now I'm ready, because I've turned my volume of copper 2 sulfate solution into moles, used my mole ratio, so I know how many moles of aluminum will be required. But the question didn't ask me for moles. Remember, the question asked me for mass. So the last step will be to convert the moles of aluminum into mass. And of course, we use the molar mass for that. 26.98 grams of aluminum per mole of aluminum. So before I pick up my calculator, I want to make sure my units are working for me. So I have liters canceling with liters, moles of copper 2 sulfate with moles of copper 2 sulfate, and moles of aluminum with moles of aluminum. I'm left with grams of aluminum, which is good because that's what I was asked for. When I put this in the calculator says 0.09443 grams of aluminum, but I only have 2 digits in my numbers. So I only have 2 digits in my answer. So my final answer is 0.094 grams of aluminum. In this problem, we're asked to determine the concentration of the acid. Well, what are the units on concentration? Molarity is moles per liter. So as this is a ratio, we need to go find the numerator, find the denominator, and then divide. I'm looking up at the problem and I see that the volume of the acid is given. So all we need to do is put that into liters, and we have our volume. Now we use the stoichiometry to determine the number of moles of HCl. So I'm looking up at the problem and I see that I was given about my sodium hydroxide both the volume and also the concentration. Remember, when I see that big M, I'm going to cross it out and write moles per liter. So now I see that to do my stoichiometry, the amount that's given is the 23.25 milliliters of sodium hydroxide. Knowing, of course, that my molarity bridge is in liters for volume, not milliliters, I'm going to go ahead and put my volume of the sodium hydroxide in liters to begin. So 0.02325 liters of sodium hydroxide. And I'm after moles of hydrochloric acid, so of course we know the only bridge that relates the amount of one reactant product to another in a chemical reaction is the mole ratio. So my first step is going to be to take the liters of sodium hydroxide and convert that into moles. And what converts from liters of a solution to moles? That's the molarity. So I'm going to go ahead and use my molarity. I need liters on the bottom to cancel. So my 0.1003 moles of sodium hydroxide is in the numerator. And now I'm ready to use my mole ratio. And again, where does a mole ratio come from? It comes from the balancing coefficients. And of course, our balancing coefficients are ones, both for the sodium hydroxide and the hydrochloric acid. So I need 1 mole of sodium hydroxide in the denominator to cancel, and 1 mole of hydrochloric acid in the numerator. Now I check to see that my units are working. Liters of sodium hydroxide cancel, moles of sodium hydroxide. I'm left with moles of HCl, which is good. That's what I'm looking for. And so I pick this up and put it into my calculator, and I see that I get 0.002332 moles of HCl. And again, there are 4 digits in that answer. Now, this number of moles, that's what I'm after in my ratio for molarity. So I just take this number of moles of HCl and I put it into my ratio. When I substitute those numbers in, I get a molarity of 0.00232 moles of HCl divided by 0.01000 liters of HCl, which gives me a molarity of 0.2332 molar HCl. This problem involves another acid-base titration, and if we look at the question that we're being asked for, We're being asked what the molar mass of the acid is. So let's go ahead and consider that. What are the units on molar mass? The units on molar mass are grams per mole. As this is a ratio, that means that I have to go find the number of grams of my acid, find the number of moles, and I'll be able to calculate the molar mass. So I look up at the problem and I see that they gave me the mass of the acid, a 0.956 gram sample. So I don't have to do anything with the numerator, it's given to me in the problem. How am I going to get the number of moles of the acid? Well, if you'll notice, we don't have a balanced chemical equation in front of us, but they did tell us that our acid is monoprotic. And this might be a word that we're not familiar with. And what this tells us is that 1 mole of our acid reacts with 1 mole of the sodium hydroxide. So I'm not needing to write out the equation. I know from this language that the mole ratio is 1:1, which means now I'm ready to do the stoichiometry to figure out the number of moles of my acid to plug into my molar mass ratio. So let's go ahead and find some information about the sodium hydroxide. I see over here that we were given the volume of the sodium hydroxide and we were also given its molarity. Remember, when I see that big M, I'm going to cross it out and make it moles per liter. That's how I'm going to see the units in my unit analysis. So now I can see that of the 2 numbers for my sodium hydroxide that are given, one of them is an amount, that's the volume. So I'm going to go ahead and start with my volume. Again, I'm going to go ahead and put that into liters. 0.0291 liters of sodium hydroxide. I know in this titration problem that the mole ratio is the only bridge that I have that links the amount of the acid and the amount of the base. So I need to use my mole ratio, but I'm not in moles right now, I'm in liters. So I need to convert from liters to moles of sodium hydroxide. And of course, it's the concentration, the molarity that does that. I need liters on the bottom to cancel, which means I have 0.513 moles of sodium hydroxide in the numerator. Now I'm ready to use my mole ratio. Again, we know from the language in the problem that the mole ratio is 1:1. So 1 mole sodium hydroxide in the denominator to cancel, and 1 mole of my acid, my unknown acid, in the numerator. Let's do a quick check, make sure our units are working for us. Liters of sodium hydroxide cancel, moles of sodium hydroxide cancel. I'm left with moles of my acid, which is good because that's what I'm looking for to put into my ratio. So now I pick up the calculator, 0.014928 moles of our acid, and we only have 3 digits in that number. So now looking back at our molar mass ratio, we now have the number of moles to put into that ratio. So the molar mass will be 0.956 grams of the acid divided by 0.014928 moles of the acid. Picking up the calculator, this gives us a molar mass of 64.0 grams per mole.